So, and maybe the audience has seen these. This is a very naive graph, but it helps to illustrate the point of what it does. So this neural network language model will have some input, which is these nodes in the, as we look at it, well, my right and your right. Okay, so the nodes here on the right are the input, and the nodes at the very left are the output. So we will present this neural network with 5 inputs, the 5 circles, and we have 3 outputs, the 3 circles. And there is stuff in the middle that I didn't say anything about. These are layers. These are more nodes that are supposed to be abstractions of my input. So they generalize. The idea is if I put more layers on top of layers, the middle layers will generalize the input and will be able to see patterns that are not there. So you have these nodes, and the input to the nodes are not exactly words, they're vectors, so series of numbers, but forget that for now. So we have some input, we have some layers in the middle, we have some output, and this now has these connections, these edges, which are the weights. This is what the network will learn. And these weights are basically numbers, and here it's all fully connected, so I have very many connections. Why am I going through this process of actually telling you all of that? You will see in a minute. So you can work out how big or how small this neural network is depending on the numbers of connections it has. So for this toy neural network we have here, I have worked out the number of weights, we call them also parameters, that this neural network has and that the model needs to learn. So the parameters are the number of units as input, in this case it's 5, times the units in the next layer, 8, plus 8. This plus 8 is a bias. It's a cheating thing that these neural networks have. Again, you need to learn it, and it sort of corrects a little bit the neural network if it's off. It's actually genius. If the prediction is not right, it tries to correct it a little bit. So for the purposes of this talk, I'm not going to go into the details. All I want you to see is that there is a way of working out the parameters, which is basically the number of input units times the units my input is going to. And for this fully connected network, if we add up everything, we come up with 99 trainable parameters. 99. This is a small network for all purposes, right?